solving trig functions with factoring. Let's kind of do a quick review. So I have two parentheses on factor this trinomial. The coefficient in front of x squares are 1, and the factors of 1 are just 1 and 1. So we can just put an x here and x here. We also know we have a minus and a plus in this order, so each of these must have a negative and a negative in there, a minus in between. And then the factors of 1 are just 1 and 1, and that's factored, okay? The second one, again, two parentheses. There's a minus and a minus, so we know in some combination you have a plus or minus. Only factors of 2 are 2, so 2x and an x. And then the factors of 6, 1 times 6, and we have 2 and 3. Okay, so usually you use the kind of do the ones close to each other, so I'll do 2 and 3. I can't put 2 in here because if I put 2 here, there's a common factor. A GCF I can pull out, and I don't want that. So I'm going to go ahead and put the 2 here, and I'll put my 3 here. And then since it's a minus and a plus, and this is a negative, this has to be a negative here, and this has to be a plus there. Okay, so let's look at the guidelines for solving by factoring. This is not new for y'all. If you think about your algebra 2, even your algebra 1, from then you've learned it and done it since. So first thing we're going to do, we're going to set the equation equal to 0, and then we factor. Remember, setting equal to 0 is just another way of saying move everything to one side, and then you'll be able to factor and so forth. The next one is set each factor equal to 0. So each of these are factors up here. This is a factor, this is a factor. And then use the unit circle to solve for the angle. Okay. Solve the following equations for x over the interval between 0 and 2 pi. Let's kind of refresh our memory again. This is talking about domain. Okay. And then we want to write it. I also want you to think of this in interval notation right here, and then think of this also in inequality notation. So now remember that this means that it is not included. 2 pi cannot be an answer, but we go all the way up to 2 pi. And so that kind of helps because I don't have a line underneath here to show that. So to kind of keep in remember, when we get our solutions, what our x can be, okay, then we got to make sure we understand that that is very important. Also to think about, remember when we're solving for x, we are looking for the angle. That's why we refer back to the unit circle. We talked about here angle. Okay. Here you see that I've got my parentheses started. I set equal to 0, but I want to make sure that we can, if you're kind of confused with this cosine squared x and that other cosine x, remember these are just variables. Think of the trig functions as a variable. So what I'm going to do is, we kind of did this in another lesson. I'm going to let a equal cosine x. So let me erase this part because this is not going to help me right now. And then what I want to do is I want to replace the cosine x with a. So I will have a squared minus 2 times a plus 1 equals 0. This will help me to maybe factor easier. You do not have to do this step, but just in case. So let's go ahead and factor. A minus 1, a minus 1. Has to be based on our rules, minus minus. Okay, so it depends on when you want to do this. I prefer at this time to replace the a. So I'm going to now replace. And then I'll have cosine x minus 1 times cosine x minus 1. I have two factors. My next step is to set them equal to 0. I don't need to set both of them equal to 0 because they're the same. So you do not have to set both of them. So then, same factor here. Do not set equals 0. Don't do it twice. Okay. So let's just do the other one. So we're going to say cosine x minus 1 equals 0. Okay. So now right here, where we're starting right here, this is actually the start of lesson 9.1. So we've only done 9-1, and we jumped to 9-3. So this is part of 9-1, okay? And so now we know what to do with that. We solve. So we take cosine x, add 1 to both sides, and we get cosine x equals 1. Okay, so here's, I'm going to think of the unit circle. Remember, we want to know where the cosine, we take the cosine of an angle, where is that equal to 1? And these are the ones we talked about before that are the quadrantal angles that are on this part of our unit circle. And again, you know this is 1 comma 0. This is 0, 1, negative 1, 0 here. And then we have 0, negative 1. Cosine is the x value. The only way that works is here at this area here. This is where cosine is 1. Okay, so now we got to think about our answer. For us, when we think about doing this in radians, this is 0, 0, or 2 pi. This is pi over 2, pi, and then 3 pi over 2. Now, because of our domain where we're restricted up here, we can only use 0. So this x value is equal to 0. 0 radians, not 0 degrees. Number 2. We have 2 sine squared x, sine x equals 1. One thing I want to bring up too, remember if I have a sine and a sine, those are the same variables. So when we talk about wanting to always make sure we can factor what we have, those two have to be the same trig function. So again, if you let a equal sine squared, or sine x, excuse me, and then replace it, you're going to get 2a squared minus a equals 1. We need to set the equation equal to 0. So move this over, and it's a negative 1 equals 0. And then now I can factor. So as long as I'm in that trinomial, everything's equals 0, I can factor. Again, the only factors we have for 2 are 1 and 2, so I'm going to put 2a here and an a here. We have a minus and a minus, so I would need plus and a minus in one of these parentheses, and the only way you can get 1 for that last part is 1 and 1. So this is a minus a, so I'm going to put minus and a plus here. And now I factored, and I'm going to say each factor equals 0. So I'm going to replace, a. Okay, so now let's replace a. So I have 2, a is sine x plus 1 sine x minus 1. Now again, just follow next step, set each of these equal to 0. And then again, right now we're going back to lesson 9.1. Okay, let's look at, I'm going to use this first one, sine x minus 1 over here on the right first. So sine x equals 1. And then going back to this unit circle, where is that x value? Where I get a sine of 1, which is the y values on here. So where do I see a 1 for y value? And that happens to be right here. So this angle has to be pi over 2. Okay, so let's try the other side. Other side, I'm going to let 2 sine x sine 4. Okay, so now I want to ask myself, just like I did before, where does sine x equal a negative 1/2? So we know that in quadrant 3 and quadrant 4, sine is negative, okay? And then we want to know what's that reference angle. So it doesn't have to worry about negative. What's the reference angle for here? What's this reference angle that I use that I can get a 1/2 when I'm dealing with sine? And if we look at you use your trig charts, whatever you're used to using to help you to determine, but we know at pi over 6, we get a 1/2 when it's sine. Okay. So I know x equals, well, if I'm thinking what I'd like to do is usually I just like to write, I know the reference angle is pi over 6. So both these have to be at pi over 6. So in the third quadrant, remember for this one, I'll write over in this little circle. These are your reference angles that you use. But we want to find the numerator for each of the following. So here, remember it's denominator -1, denominator down here +1, and then here it's 2 times denominator -1. So if I'm in the third quadrant, I look at the numerator, take 6, subtract 1, and I get a 5 pi over 6. For quadrant 4, 2 times denominator, so 6 times 2 is 12. 12 minus 1 is 11, so this is 11 pi over 6. So all of these values here are true for this trig equation, all three. Number 3, we're going to move the tangent over because we got to set the equation equal to 0. So I'm going to subtract tangent x, or excuse me, add it to the other side, equals 0. Now we're going to factor. We only have 2 terms, so when we only have 2 terms, remember you want to look for the GCF. Now if I wanted to, I can let a equal tan x. And again, so let's just kind of do that so we make sure that we see what we have, okay? And then I'll replace it. The GCF for a squared and a would be just a. So we're going to factor out an a, and that leaves me with a plus 1. Remind yourself that if you take out the a, distribute back in to see what you're, if you're correct, that you factored correctly. Another way to do it, if you feel like you're going to make silly mistakes, I'm dividing an a from each term, is what I'm actually doing. And that's how I get what I got. So at this point, I'm going to replace a, and so a is tan x here times tan x plus 1 equals 0. All right, so now we're going to set each equal to 0. And now we are in lesson 9.1. And keep writing that because once you go to, you can refer back and forth. Okay, so now that we set each of these equal to 0, we're going to solve. So let's look and find out what x is. So let's look at this first one. The thing about this one is you want to know if I have a tangent, okay? Tangent is the same as sine over cosine. All right. In order for tangent to be equal 0, okay, we have to make this equal 0, this fraction. Now remind yourself, what makes a fraction 0? Okay. So if I have 0 over 1, let's kind of review that. 0 over 1 and 1 over 0. Okay, those are two different things, right? But if I have a 0 over 1, 0 divided by 1 is 0. But if I have this one, this is undefined. Can't divide by 0. So the thing is reminding yourself which is which. If you need to, then, you know, you can literally put it in there or find the values. But I want to know if this is true based on this. That means whatever's down here. This can be anything. I just put 1 for easier sake. Any number down there. Any letter down there. 0 over anything is going to be 0 no matter what. So when I look at my fraction here that I've created here, sine x has to be 0. I don't care what cosine x is. I just want to know where is sine 0 at. Okay, so when I look at my chart, again, when I'm talking about zeros, negative ones and ones, for cosine and sine, you're always going to use the circle up here. Okay, so looking at the circle up here, our unit circle, where is our sine equal to 0? So we see sine of 0 is always the x value. So it has to be here and here. Don't mess it up. Okay. So I know at pi, and at 0 to pi, but again, we can't use 2 pi. So sometimes you might just want to leave that off for now, since we can't use it. So that means x has to equal 0 or pi. It's the only way it's going to work, okay? Now let's look at the next one. All right, tan x, we gotta set equal to -1. Okay. Now, in order to, if you remember, we talked about before. The only way you get 1 or -1 for tangent and cotangent, because it's a fraction, sine x over cosine x, these things have to be exactly the same. So any number itself would do it exactly the same. Okay. The only way that works for tangent is at pi over 4. Because remember, the sine of pi over 4 is square root of 2 over 2, and the cosine of pi over 4 is square root of 2 over 2. These have to be exactly the same in order for you to get a 1, or that one of them has to be negative to get a -1. So either one of these work. That's going to come into play when we think about what quadrant it's in. So let's look at what quadrant it's in. We are in, where is tangent x negative? So tan is negative at quadrant 2 and quadrant 4. That's where tan is negative. Okay. And then, so x equals, we already talked about the reference angle. No, we did right here, reference angle. This is when that's pi over 4. So I'm going to go put my pi over 4 for quadrant 1. There's my reference angle, quadrant 2. And according to my little chart up here, my little mnemonic, it has to be 1 less. So this has to be 3 pi over 4. And if it's in the fourth quadrant, again, we'll have a pi over 2. Pi over 4. And we look at the fourth quadrant. So 2 times the denominator, which is 4. 4 times 2 is 8. Minus 1, and we get 7 pi over 4. And this is our solution, as well as this. Number 4 example. When I look at this one, I want to think about, again, I only have 2 terms. It's r set equals 0. I have 2 terms. And just what's the GCF between these two? What I see the same. I can let A equal this and B equal this, but I think it's easier just so you can see it. I have exactly a cosine squared x and a cosine squared x. So that's going to be my GCF. So that's right up here, so you see what I'm pulling out. Okay. So with that said, let's factor that out and then see what we use to find those values. Again, let me move this down a little bit. When I'm trying to factor out something, I'm going to divide everything by what I see. So up here, I'm dividing by this. So that leaves me with just a cosecant x minus anything over itself is 1. And that's going to equal 0. So now we're up to where we're got our factors. Now set everything equal to 0. And so we have cosine squared x equals 0. Cosecant x minus 1 equals 0. Okay, now that we've got them set equal 0, this is really lesson 9.1. Okay, so when I solve for, I need a cosine. So where does cosine x equal something? So I take the square root of both sides, and I get cosine equals 0. We can't take the square root of 0, and it's just 0. So now I'm going to see what, on my unit circle, where is cosine equal to 0? So I'm going to go over here. Again, I'm looking at the x values. Where does cosine x equal 0? So that would be here at pi over 2, and then here, 3 pi over 2. It's 2 places. So I'm going to write x equals pi over 2 and 3 pi over 2. All right, let's solve for the other side, find our other value. Here we have cosecant x minus 1, so let's move that 1 over. So we get that -1 over cosecant x equals 1. When we think of cosecant x, we're going to think of reciprocals. We want to do in sine and cosine and tangent because we know those. Everything else we can use after the fact. Unless you've memorized all of them, every single one of the trig values for all our 6 trig functions, it's just easier to work with your reciprocals. So here this has to be 1 over sine. Okay, so right here, I have 1 over sine x, which is the reciprocal of cosecant x equals 1. Remember, the reciprocal means just to flip a fraction over. Here, from here to here, I used the trig identity. So what I'm just going to do now mathematically is I'm just going to do mathematically and do the reciprocal. So that means I'm just going to flip this one over. When I flip one side, I have to flip the other. Reciprocal 1 over 1 is just 1. Okay. So now let's go to our unit circle. Where is sine x of some angle equal to 1? Remember, if you have 1, -1, or 0, you're thinking of those quadrantal angles that are on the axis itself. And so if I look at this up here, I see that 1 is at pi over 2. Okay, since I see a pi over 2 here, I don't have to write it twice for my final answer. So this is the answers. Again, we don't need to repeat the same thing. It means the same thing no matter what I use.